Hello, everyone. Good evening to Indian participants and for the participants outside the country. Good morning to them. Good afternoon to according to their time zone. I welcome you all for this project session series, and I'm really glad you have opted this project sessions. A very important one considering the kind of projects, considering the kind of statements, problem statements which we have took in this entire series of machine learning and deep learning, which includes your domain related to regression algorithms, classification algorithms, time series. Also, we will be dealing with computer vision problems, natural language processing, and also there is one project related to the large language models fine tuning that we are going to pick up at the last. Okay, so this entire program is based on 10 projects, and in these 10 projects, what I told just right now, such problem statements are considered. Okay, and this is our opening day of the project sessions. I expect, as I already mentioned in the group also, that your sincerity, your discipline, your contribution is been required here in terms of knowledge sharing, because I know that there might be the people here who joined this session already know about data science, machine learning. You are working in this particular field, you have a knowledge. So I request with me, as I'm going to deliver the session to you all. Meanwhile, your thoughts are also welcome. However, I want to make this session like interactive and like the way we'll go in a fluency. I request you all keep yourself muted while I will be talking about the entire project explanation. And if you face any difficulty, you can unmute yourself and you can ask anytime. No worries, not an issue. Okay, the theme of this program, it's not to cover the 10 projects, it's to discover what is hidden in the data science and machine learning, because it's all about world of data. Data are raw facts and figures, and we do process data to have an information. And obviously here I am having, if you say data, also numerical numbers. So numbers are magical. Fine, we have to learn this magic. We have to learn how to work over the data, different kinds of data. Okay, according to the problem statement which is being given to us. And I sorted all these important problem statements. That is, our first problem statement is related to energy prediction. That's what the title is. Okay, so let's proceed ahead. And I welcome you all, and I wish all the best to everyone that we are going to learn a lot in this training program. Okay, meanwhile, I request everyone to keep your camera off. Okay, keep your camera off, be muted, and in case if you are having any problem, then you can unmute and you can speak. Okay, rest you have to keep your camera off and okay, mute yourself. Fine. So let's get started with the first project, that is forecasting and analyzing renewable and non-renewable energy generation and demand patterns using machine learning and deep learning techniques. Okay, the title named like sir, it is big one. Of course, because I am available with the energy data. See, what we are going to do here is we have to understand the title, we have to understand the problem statement, we have to understand the data, and then we have to do the implementation also. Okay, fine. So the title says that forecast and analyze the renewable and non renewable energy sources, energy generation. Okay, and what is the demand for them? We do produce the energy by different means. It can be like renewable, it can be non renewable, something which can be like renewable source of energy, which we say, okay, not been exhausting, it will be continue. Non renewable, okay, I can't have this thing so long, that is for some limited period of time. Okay, so we are using these sources to produce the energy, and then we are going to deliver them for the use. So, if there is a usage, what is the demand for that, and how much we can produce? Okay, so the title, forecasting, analyzing renewable, non-renewable energy generation. We are available with the data where the details are mentioned related to it. Okay, and then the word forecasting, every term, if I would like to introduce forecasting, you very well know in data science and machine learning we do perform forecasting, we do perform the prediction. Okay, so that is like predicting the future. Okay, and the term energy, if I would say what it means, energy. Energy is the ability to do work, it is the capacity to do work. We are right now dealing with the problem statement of energy forecasting for renewable and non-renewable. So obviously the production of energy here will be related to kilowatt hour. Okay, that is the amount of energy consumed by 1000 watt appliance running over 1 hour. Okay, that sense of energy we are talking about currently. Okay, kilowatt hour. This will be the measure of energy in our terms of the data set. Okay, so we have to predict the energy demand. We will be available with the sources, different kind of sources, renewable, non-renewable, all entries will be mentioned in our data set. These sources are available to us. We have to predict using these sources. Okay, demand is also present with us. Target variable is there. Okay, and we have to train our model over this particular data. Okay, and the purpose of this project is to develop the models that can accurately predict the demand. Okay, considering both renewable and non-renewable sources. Okay, we are going to analyze. That means you very well know EDA, exploratory data analysis. We are going to analyze our data. We have to identify the hidden patterns in the data, what our data means. We have to talk about the trends in the data, what kind of decisions we can take. So ultimately we have to perform the entire exploration of the data, each and every feature, what does it mean, and how it is related to other feature, what kind of trend we can see in this particular data, everything we have to understand. Okay, and then this renewable source of energy, that is from the nature, solar, wind, geothermal, hydroelectric. Okay, so from the nature, and something which is not from, like with finite source, like fossil fuels, coal, oil, gas. Okay, which may come to an end after some limit of time. So such kind of energy is non-renewable energy. So right now we are mostly using this non-renewable energy. However, we are shifting towards the solar panels. If I do talk about my country, Okay, so we are using the solar panels. Okay, some battery operated, like machines also, in driving vehicles also, if I would say. So we are switching towards this kind of system, just keeping in consideration that this non-renewable source of energy, after some years, it's going to be replenished, so we will not having them again, or it will take a lot of time to recreate like this kind of energy. Okay, these sources. Fine. So renewable and non-renewable. Energy demand, very much important. Very, very much important. Such kind of project should have to be there in your profile. Everyone now, you are working in some industry, some institution, and there is a demand of energy. Okay. There are many consumers now of energy. So demand is continuously growing on. For that, you have to look out for the production also. No? Okay, so this project focus upon analyzing how much energy demand will be there. Okay, for example, tomorrow, how much energy I require? Day after tomorrow, how much energy I require? Okay, today is such kind of a trend seen, but what after that? Whether the trend will be same? So day by day, either we can focus upon this thing, because in my data set it is given. Okay, what is the energy demand next day? Then what is the energy demand like in this particular, I'm available a feature in my data set. I will be explaining each and everything, don't worry. Okay, so we are just focusing upon that we can produce the energy and what is the demand for that daily basis also. Okay, and then we have to use our machine learning and deep learning algorithms related to it. Fine. So we are having many regression algorithms like linear regression, decision tree, support vector machines. These are ML. And deep learning algorithms, like we have to make a neural network. Also, we can apply the time series, because in my data set I am available with one of the feature as time. So I'm going to interpret this thing to include time series analysis also. So we'll be doing, in modeling part, we will be doing regression analysis, we will be doing time series analysis, that will be separate. Okay, so this is the introduction, and the problem statement I already told you. Because once you are available with a project, you have to, don't directly jump over it. From industry, I know that you guys are working from industry, you will be giving a problem statement. Okay, you have been given a title. Okay, that this is the title, this is a problem, take the data, and that will be a raw data, messy data you have been given. And then you have been asked, come on, you are expert now, do work on it, perform the entire analysis of the data, and if you are expert in modeling, automate the task. So what's the problem statement here? We have to forecast energy requirement, okay, according to the demand. That means we are available with the energy generation, we have to look out for the demand. That is a critical challenge. That is a critical challenge because the things are fluctuating. Okay, and you can find many research papers over this also. Machine learning and deep learning algorithms used for energy prediction. Fine. So we have to better understand the patterns in the data, and then we have to apply our machine learning and deep learning algorithms. So problem says that you have to forecast of energy generation and demand. Especially, I'm talking about the demand. Generation is there. Okay, there are two things can be used here according to the data. We can look out for the generation also. We can look out for the demand also. Our main goal is to look out for the demand. That's what our project says. Okay, fine. Now, this is the overview of the project. Introduction, problem statement. I hope you got this thing. So before indulge into a project session, you have to understand what is given to me. What are you talking about? Let me go through the basics, because domain knowledge is also important na, in data science. Without domain knowledge, how can you do any project? So I just gave you domain knowledge, introduction, problem I told. Now the next thing is you have to look out for the data, what is available. Okay, so here is the data description. Before data description, let me show you the Excel sheet. Here is the Excel sheet. Okay, this is my data set. In my data set, there are many features available. All are related to energy production, okay, generation, and we are having the demand also mentioned here in the data set. You're seeing that, okay, the first feature is time, and the time here it is mentioned 2015 1 plus 0 1 colon 00. Sir, what kind of pattern is this? Okay, a few things we can understand. Okay, 2015 year, one is the month, one is the day. Then 00 that means are you talking about 12 in the night, 12 a.m.? That means from the time where the day starts. I think you are going to talk from that.
Yes, sir. Yes.
Okay, fine. And then after an hour, then after 1 hour, then after 1 hour, that means this is 1 a.m., this is 2 a.m., this is 3 a.m., 4 a.m., 5 a.m., 6 a.m., 7 a.m. That means for the same day, you are considering 24 hours, entire 24 hours. Energy generated, how much consumed? Energy generated, how much consumed? वो तो अभी आगे आएगा भाई यहाँ पर. अभी तो सिर्फ टाइम की बात कर रहा हूँ. I'm just talking about the time. You are having entire 24-hour program. So okay, till 23 तक ये देख लो, वो जीरो से स्टार्ट हुआ है till 23, that means 11 p.m. Okay, fine. Now date is changed, 2015 0102. That means another दूसरा दिन हो गया, second day. Again you are going to start from here. So ये time है. Okay, now let's talk about the time. What is the description available to us? This is timestamp of the recorded data, including the date and the time. It contains the time zone also. Plus 01 is the time zone actually. Okay, so data set might be taken from European country. So there are such kind of time zones are mentioned. Okay, fine. So this is like UTC, European time zone, something like that. Okay, so plus 01 is related to them. However, the main concerning part for us is that year, month, and the day, along with this hour, minutes, and the seconds. Okay, in our data set, hour, minutes, and the seconds. That is enough for us. Okay, then this is your plus 01 is your time standard, time zone. That is the same for all. No difference. And we are starting our data from 2015. I think it will go till 2018, 2019. So 3 to 4 years, hourly data is available to us. Good one. Hourly data. How much produced, how much consumed, required. Hourly data. 4 years, 4 to 5 years. Okay. Then generation biomass. Okay, so how much kilowatt of energy generated? Megawatt, not kilowatt. Kilowatt में तो बल्ब बल्ब जल रहा, मेगावाट में चल रही. Amount of energy generated from biomass. That is organic material, fuel. Then, okay, you can see the entry. Check the entries also. What kind of entries are there? So numerical. This much megawatt of energy generated by biomass. Then generation by fossil brown coal lignite. Okay, so what it is? Energy generated from burning brown coal or lignite. Okay, by burning coal or lignite, how much energy is generated? That is also mentioned. Megawatt. That is also mentioned here in the data. Then generation fossil coal derived gas. Okay, so here what is derived gases generated, this energy generated from the gases produced by gasifying and or other processing coal. So there might be like when you burn, so there will be some gases which are produced. So such kind of gases are coal derived gas. Coal is na carbon format, so it can react with other forms also, na, like oxygen and other things, so it can convert into some gases. Okay, chemical compounds, what you can say. Then I'm having generation fossil gas. Okay, you can check generation fossil gas. And if I check the entry of this one, previous one, fossil coal gas, so it's mainly zero, 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 zero. A lot of terms are zero here. Some terms are empty also. So it's all zero. That means nothing has been produced by this gases in our data set. It's all zero. Okay. Now fossil gases, this much amount of energy generated. Okay. So fossil gases are like CO2. And now we carbon gases. Okay. Fine. Which produce greenhouse effect. This person CO2. It produces greenhouse effect. It gets collected in the atmosphere and block the sunlight to pass. Okay, to escape greenhouse effect. Okay, then generation fossil hard coal. Okay, then generation fossil oil. So such kind of data is available to us. All the generation fossil fuels, na related renewable and non-renewable. So so far, what we are seeing is non-renewable. Okay, these all are non-renewable. Whatever we considered as a fossil fuel, non-renewable. Okay, then we can jump to some renewable sources like, okay, we are having some geothermal also, hydroelectric. Okay, hydroelectric. Now, what this term means? Generation hydro pumped storage aggregated. That means total energy generated through hydroelectric pumped storage, where water is pumped to higher elevation during low demand. Okay, there is a sense in this. There is a sense in this. Okay, and what is the next point? Generation hydro pump storage consumption. One is aggregation, one is consumption. Understand what kind of data it is. Okay, when the demand is less, प्रोडक्शन तो हो रहा है भाई, प्रोडक्शन वॉज देयर लेकिन डिमांड कम है. फॉर एग्जाम्पल इन winter seasons demand is less but production is there, so we don't want that to be wastage, so we are actually now storing it. So in case when there will be high demand, so whatever we are stored, we have stored, we can supply to it. Okay, so production is there. We haven't stopped the production. That okay, winter season came, so production stopped. Okay, no company is going to have afford a loss. Okay, however, we are storing the energy. Okay, when demand is less, store, and when the demand comes more, supply. This thing also supply. Okay, so hydro pumped storage aggregated. That's what it means. Okay, so to release it when there is a peak demand, meanwhile kindly store it. When there is a low demand, store. जनरेट तो हो रही है, उसको रोक तो सकते नहीं. Okay, fine, this is the consumption, the amount of energy consumed pumping water uphill in hydroelectric pump storage systems. This is typically a negative value and it represents energy used rather than produced. Okay, that means amount of energy consumed in pumping water uphill. Up. Okay, that means we are using motors and we are pushing the water to go from low level to higher level, uphill. Okay, in above case we are storing, and this is the introduction. The amount of energy generated using heat from the Earth's core, that is geothermal, because of heat, and these are hydroelectrics. All these are hydroelectric. Okay, Then generation, hydro runoff, river and poundage. That means energy generated by hydroelectric plants using natural flow of water. This is what we use. We make dams, na reservoirs. Okay, in general we make reservoir, but here it is saying that by runoff river without any reservoir, without any dam, just running. Water is running na, and you are introducing some setup, so that is helping in generation of energy. Okay, with some small water storage for balancing purposes. So with the run of water, you are producing some energy. So there are different ways, different techniques by the help of which you can create the energy. This one is the reservoir. Why creating dam? This is the general one. On rivers, we make dams, and water fall down over the turbines. Turbines started rotating. Energy is produced. Okay, we are having electrical systems, so it is produced, and then it will be transferred to one end to another, and with the help of transformer. So that's what happens. Okay, so this thing, hydro pumped, aggregated, hydro pumped storage, runoff water, runoff river, and this is the reservoir related to hydro, related to the water. Marine, that means tides and the waves. For example, at the oceans, they do have some setup when the tide come or something like that. So with that also energy is created. With nuclear energy. Okay, many of the countries do have this kind of setup. Okay, but okay, it's one of the risky thing. But however, because the demand is more, and if the sources are like been in extinction, what can we do for safe purpose? If this is been applicable, you can apply nuclear generation. We are having other sources also generation. Okay, then generation other renewable like different kind of setup. If they have been done, and we are producing the energy from them. Solar energy also, from the waste also, from the waste materials also we are producing the energy. Wind offshore and the onshore. Okay, that means the wind turbines which are located on the offshore, that means in the oceans, in the lakes, in the sea, turbines are there. So the energy which are produced from, so this is offshore. People may do confuse offshore, onshore. Offshore means like in the oceans, in the sea, or in the lakes. Wind turbines are there, so that is offshore. Onshore means on land actually. Okay, that means if the turbines are located on land, that is onshore. So shore means a land, off means not on the land, in the sea, ocean, river, water, whatever. Okay, then we are having forecasting. So all these not till 22, from 1 to 22, these are the sources of energy. We are generating the energy. Okay, the first one is the time zone. Rest are all the means of energy generation, either by biomass, either by fossil fuels, either by geothermal hydro plants, okay, by nuclear, by solar, by waste, by offshore, whatever be the means you are available with to produce energy, they all are mentioned here in the megawatt. And then this is something which we are looking forward to forecast. What is the forecast solar day ahead? That means prediction of energy in the next day, and forecast offshore day ahead, that is also been mentioned. Okay, we are having other features also. I guess we can use this thing for the forecasting. However, they are mentioned that what is the next predicted value for the forecasting solar energy generation next day, for offshore next day, onshore next day. Okay, so next day how much is required, that is also available related to these three: solar, offshore, and onshore. Then the total load forecast, that means the forecasted total energy demand or the load on the grid for a specific time. Okay, so obviously now there are grid of this energy. There is an entire electrical network that is called as a grid. So how much total load forecasted on the grid? depends upon the demand, or like now how much it is demanded and how much it is supplied. So what is the total load on the grid? So that's what the forecast values are mentioned. Total load mentioned. Okay, what is the total load? That is the total energy demand or the load on the grid for a specific time. So this is the forecasted. This is the available total energy available, and this is the forecasted. Okay, and the last two are the price day ahead and the actual price. That means price day ahead means predicted or a set of energy price for the next day. Okay, what will be the price for the next day? We are producing this much energy, so kindly tell me what is the price tomorrow. What is the price of energy tomorrow? And this is the price actual. That means the price of electricity in the energy market at a specific time. Right now, what we are paying. So the price of the energy or the electricity which we are consuming, that are not on the daily basis. Okay, they are decided but not like on a daily basis. Okay, sometimes the government do increase the price of the electricity according to the units consumption. Okay, that means 4 unit or 5 unit or 6 unit per, okay, consumption according to the India I am talking about. Okay, so this is the price day ahead and this is the actual price. These two are the ones which we are looking forward to have as a target feature. Okay, either of them we can put as a target feature. However, I'm looking for this price. Okay, so let me again simplify this data set, as you have seen a lot of things here. Okay, so when you are doing a project, you see a lot of features present in the project. It's not directly again to proceed. Understand, and it is mandatory for each and everyone to do some hands write some write up. You should do some write up. Okay, so what is available to me? Okay, the project is related to energy. Okay, you are talking about consumption, and you need to forecast. Okay, you need to perform the forecasting, and there are many things which are present in my data set related to the forecasting. It can be like a price forecasting, it can be like an energy forecasting. Okay, there are many things which are available in the data. Okay, uh, according to me, the problem given is, okay, what is the price? What is the forecasted price? Okay, and in my data set I do have available with the date. Okay, where I am having 2015 as an year till 2019 as an year. This much data I am available with, and 24 hours data has been given to me. Hourly basis data is available to me. Okay, hourly basis data we are dealing with. All right. So this is what in data I am having. Then rest I am available with the sources of energy, renewable also and non-renewable sources also I am available. Okay, in non-renewable sources the data says that, okay, you are using fossil fuels. This data is available to me in terms of coal and the natural gas. Okay, so coal and natural gas, it is available to me. Fine. So such kind of production or the generation is available. In renewable I do have something like related to the energy which is generated by core of the earth, the energy which we are generating with hydropower. Okay, in hydropower also we are having many things. Okay, either by storing, that means creating dams, either by running of the water. Apart from that, we are using other techniques which I told that, um, if the demand is less, then you are doing the production and you are saving the energy. That's what you are doing. Okay, sometimes you are using your motor or the engines to send the water on the uphill. That is what also you are doing. Okay, so such kind of data is available to me. For some features, I do have the next day predictions. That means related to the solar, related to the onshore, related to the offshore. Onshore and offshore also production I am available with. Offshore means, okay, I am having the energy generation that is not in the land, that is either in the sea, ocean, and onshore I am having on the land. This is what I'm having. Megawatt is something, the unit of the data which is available with me. Okay, I should be knowing about energy, I should be knowing about the electricity here. Okay, what do you mean by the electricity grid? Okay, because these are the powerhouses. Okay, from where you are generating the energy. These are the powerhouses. You are generating the energy and you are supplying it to the grid. And obviously, grid is the distribution authority. Okay, from here, the distribution occurs of the electricity to the various nodes. The grid distributes. So at the grid also, I need to take care that, okay, how much is the predicted next day energy I am receiving? What is the current storage at the grid? That is also been available in the data set. So entire from the production till the storage to the till the supply, and what is the price, everything is given to us. This is how you have to plan in your project. This is how you have to make an understanding. Try to prepare a layout, what each and every feature means, what is the entry present in each and every feature. Okay, a proper plan needs to be done. So data understanding, the step number one, understanding is very much important for you. And that's what we have done by seeing this Excel sheet, that I'm having so many features available. Okay, and if I do check the entry, okay, fine. Here are the entries, numerical entries, numerical entries. Okay, here are all zeros. That means I think we haven't utilized coal derived gas. Okay, fine. We proceed ahead. Okay, here also the numerical entries are present. Zero, zero, zero. Okay, that means we are not utilizing these sources. Okay, and again, here are the numerical entries. Some were zero. So my entire data is numerical based only, except the one which I see in the form of a time. This is not numerical. This is object type. Okay, according to my analysis, I am right now I'm interpreting that my entire data is numerical. Only just time is not numerical. Rest all are numerical data. And here we can see price day. That means the price day ahead. That means कल का क्या price होगा? What is the price tomorrow? And this is the total price actually. This is the price actual. ये तो predicted है. And this is the actual price. Okay, this came under the prediction. What is the price? And you can see that there is a change in the price. It's not like same. It's not like same. Because you have to understand, that is the theme of the project. Theme of the project. Not every time we are expecting the production of energy as same. Production is not same. Sometimes production can be high, demand can be low. Sometimes production can be low, demand can be high. Sometimes production is also high, demand is also high. Sometimes both are down. We don't have any a regular pattern. You are including fossil fuels, you are including renewable sources also. So it's not like that. No, wind is blowing every day at the same pace, water is flowing at the same pace. No, or the gases are producing, or whatever be the biomass, any kind of source which you are taking, it's not same. You can see that in the data it is clearly mentioned that, okay, on this particular time biomass produced 447 megawatt of energy. On this particular time it produced 449. In this particular time it produced 448. So obviously there is a change. If there is a change in the production of energy by these sources, accordingly the prices are also kept dynamic in nature. It's not only that the explanation of each and every feature is given to us, so we are just going to read it, but we have to understand also what actually happening besides the story. Okay, so from here we decide that okay, we are having all these energy production features available, and the target is we are looking forward for what could be the actual price. Okay, this is what we are targeting. Okay, the one which I have decided, either you can take price day ahead also as a target. Price actual is something which I'm deciding from my side. Either you can take total load forecast or total load actual. This can also be put as a target. Okay, that means energy load. We can predict how much energy load could be. That is also one of the possible option in our data. Depends what kind of problem statement given to you. Right now, I'm assuming that the problem statement is the price prediction. Okay, and let us confirm our forecasting renewable, non-renewable energy generation and demand. Okay, so we are talking about the demand. So in case of demand, how much energy is required? Okay, so in terms of demand, what do you think? What could be our target feature in terms of demand? In terms of demand, what could be our target feature? I'm right now considering price. You are available with load also. Okay. So either you can take these, either you can take these. Okay. Time I already told you. Okay. So this is your year, month, and the day. This is your hour, minute, and the second. Okay. Plus one is your time zone. That is UTC, Coordinated Universal Time. That is according to the European time zone, I guess. That's what you are having. Okay. So this is all about data. After understanding the data, you should have a plan for execution. You've seen your data and you came across that there are many features. Features are related to energy production. Price is also there, load is also there. Okay. There are numerical entries in the data. There are few entries which are empty. That means I am having null values also. So this is kind of messy data available to me. I will be taking some action over this particular data. We'll consider what kind of action we require to take over it. Fine. So what we are going to do is, okay, we are going to take the data, we are try to do the EDA for the data, and there we will see, we perform the visualizations also, how features are behaving. So all these things we try to analyze the data, and then later on we'll proceed to the modeling part. But before that, these terms are very much important. Okay. So now, do you want to say anything? Do you want to ask anything? Please go ahead. Else I am available with the code and we will be doing the implementation. Do you have any doubt? Please let me know. Anything you want to say? Data understanding is very much important. That is the primary step. Yes, yes, Mr. Akshat, you can say.
So what did you mean by EDF?
EDF.
You said EDF of the data, something you mentioned towards the
EDA,
end.
EDA, EDA.
EDA. No, it's not EDF.
EDA,
It's
Uh,
exploratory
exploratory
data.
data analysis.
Hmm. Exploratory data analysis. Okay, I
Okay.
need to analyze my data and I will be exploring the insights which are present in the data. I want to know more about the data, what it comprises of. That is the EDA part. We are having the visualizations also included in that. Sometimes I do write separately, okay, make the visuals separately, take the data visualization. Okay, so that is EDA, not F.
Okay. Thank you, sir.
Okay, fine. Rest, do you have any issue related to the features which are in the data? Because these features are being understood by the experts who work in the energy field. This is like domain problems, domain specific. Okay, sir, from where you got the predicted value energy demand ahead? Predicted value of it's already available in the data set. Sir, all these things now are available in the data set. That's what I explained. And correction of the data I took from the Kaggle. Okay, this data is available from the Kaggle. Okay, renewable, non-renewable, all these things are available on the Kaggle. So I took such data which is having more scope of work. Okay, so still I request everyone that go through these features again. Okay, what they mean. And meanwhile, I guess during the implementation also, I will re-explain wherever it is required. Okay, fine. Now, here is my Jupyter notebook. I've already shared with everyone the Jupyter notebook. Okay, the code which I have done from my end. So I gave the title over which we are working. I added the title. I added the image. I hope you know how to write the title and how to add an image in the Jupyter notebook, because this is the way I do the code. Okay, if you're doing a code, you're doing a project, at least give the title, give the heading, add the image to it, what kind of project you are working. So kindly do that. Okay, and from here the actual code starts. Let me increase the length. Okay, from here the code starts. So step number one is, okay, what I teach every time: if you know or if you don't know what to do with the data, at least these are the basic libraries that you have to import: NumPy, Pandas, Matplotlib, Seaborn. Okay, this is what you have to import. Okay, fine. So NumPy, obviously numerical, Python to do the maths, Pandas for the data frames, Matplotlib, Seaborn visualization library. Okay, then warnings. This is optional library. During the execution of the code, when any of the warning appear, so I want to ignore it. I want to deal with the error, not with the warning. Okay, so import warnings, warnings or filter warnings, ignore. Another library I have included here. And then I took my data, energy data set CSV, that is available with you, including the code. I took this data and created a data frame. You very well know what is a data frame. Okay, it's a table, it's a row column arrangement. That's a data frame. Okay, and my data is a CSV file, na, comma separated value, CSV. There's an extension of this particular file. That's what I was showing you. Excel make format है CSV वाला, comma separated values. So that's what I am having. So I took the data, read CSV, and then I printed head. That is the first 5 rows of my data. Okay, df dot head, first 5 rows. Df dot tail, next 5 rows. That means the last, not next, last. Tail. So tail is the last 5 rows. Head is the first 5 rows of the data. Okay, just to, like, now this is also kind of an exploration. Okay, this is also a kind of an exploration. What we are doing over the data. Head and the tail. Exploration. Okay, and then df dot shape. Okay, how many rows and columns are there in the data? 35,000 rows, 29 columns are available in the data. Okay, it's a good data. Okay. Df dot columns will print how many columns, that is the name of the columns actually. Df dot columns print the name of the columns present. So you can see that these are the name of the columns which are present in the data. Okay, every column, every feature, what the meaning, what kind of entry they do have, that I have shown you, I have explained you in this particular data set. Okay, that's what I have explained. So it is showing the column names, df dot column names. Okay, and this explanation I have also included in my notebook. every feature what they mean. The entire explanation I have included in my notebook. Okay, what is renewable, what is non-renewable, okay, what every feature means. Now, you have taken the data, you are available with the data frame now. Okay, you are available with the data frame now. The next thing is, okay, you did see that my data is having null values. There are two things to perform some sort of cleaning in the data. The two basics are, that is, first one is the duplicate, second one is the null values present in the data, because working with the duplicates means, okay, it's just like the same thing. That means it is having the same points. Okay, and null values means nothing, empty. So if you are available with the duplicate values in the data, that means duplicate, especially we are going to check the rows. Okay, rows. And null values, we are going to look out for each and every column. Okay, so null will be column. Are there null values in the columns or in the features? That's what we have to check. Because duplicate are going to represent the same point. Null values, they are going to show nothing. But we can't work with the null values. Okay, keeping value empty in a data set, that means when you are going to use this data ahead for modeling purpose, model is a mathematical equation. Okay, it's a mathematical equation, and in equation there is no sense of putting null. It will throw an error. It will show that, okay, there is a nan value present. It will throw an error. Fine, so we can't do the code for the model, especially using the null values. So df.duplicated.sum, check the duplicates. So right now I don't have any duplicates present in the data, it's zero. Then df.isNull.sum to check whether there are null values present in the data. So you can see that, okay, I am having many null values present in the data. Okay, almost every feature is having null values, some null values, and total it's more. And I guess in hydro generation pumped storage aggregated 35,000 null values. Here also, forecast wind offshore 35. That means the entire column is null. Forecast wind offshore. Again, how many entries we are having in our data? What is the total number of entries? 35,064 only. And these two features are showing entire null. That means there is no sense of keeping such features in the data. They're entirely null. So what I did next is, first let me print the information of the data. Okay, here I identified that there are null values present in the data. Duplicates I don't have, but there are null values present in the data. And I already informed you that, okay, we can't use the null values. We can't have in the modeling part. So we have to fill them. Now there is one more thing. Null values needs to be filled. That is called as imputation. And imputation is decision making. Okay, we have to take a decision. With what value I can fill this null? That I will help you in how to make a decision, what action you have to take. Right now, I identified that there are null values present in my data set, and I have to take some action that I will take ahead. Okay, and two columns are entirely null. So there is no sense of keeping those two columns. We will be dropping them ahead. Okay, so here you can see after identifying the null values, okay, I printed the information df info. Df info will let you know that what is the data type specially. It will also show you the entries. It will let you know about, okay, from this to this entries are present. Total 29 columns are there. These are the name of the columns, and yeah, this is the data type. Especially, I do focus upon data type and info. So, as I told, time is object type. Rest all are numerical. Float 64, float 64, int 64, float 64. So, int and float are the numerical. And 64 is because my machine is 64-bit operating system. That's why it is showing 64 at my machine. Okay, because it takes 64-bit representation to show a numerical value. That's why 64 is been mentioned here. Okay, so this is the data type of the features. There is one more thing. Df describe to describe data. Description in the sense, okay, what is the total count? That means the number of entries. What is the mean of each and every column? What is the standard deviation? That means this description totally means statistical description. This is statistical description. Like, okay, I'm talking about the mean, I'm talking about standard deviation, I'm talking about the minimum value, maximum value present in the data, along with 25%, 50%, and 75% distribution of the data. That's what I'm talking about. This is entire statistical description of the data. Okay, so what you have seen here, you've seen mean for each and every column. Remind you that this description is only shown for numerical columns. Remember, not object columns, only numerical columns. Df.describe is for numerical columns only. So here we are printing mean, standard deviation. So standard deviation, this when this word came now, variance came into the picture. Variance, okay, variance means, okay, um, how much a point is away from its mean. That is a variance. And square root of variance is a standard deviation, SD. Okay. So again, statistical terms these are. Then I do have minimum value in the column, maximum value in the column, these two. Then, more importantly, again, 25%, 50%, 75% distribution of the data. What that means? Okay, if you're expert, you already know about that. These are quantiles or quartiles. Okay, that means I am dividing my data into four parts. I am dividing my data into four parts. How? What are you saying? I am saying that, okay, for example, you do have a column, you do have a feature. Okay, pick up any feature from here. Pick up any feature. Okay, let's talk about generation biomass. Okay, so generation biomass, it do have numerical entries present in it. So what the system is doing, it is arranging it into ascending order. Okay, like for example, I can say like one, two, 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 three, four, five, six, seven, like this ascending order. And then what it is doing is it is dividing this entire data into four parts. For dividing a data into four parts, I require 3 points. If you have to divide a data into four parts, you require 3 points. These points are named as Q1, Q2, and Q3. Part 1, Part 2, Part 3, Part 4. So dividing data into four parts, we require 3 points, and these 3 points are, okay, one is 25%, one is 50%, one is 75%. This Q1 is 25%. That means below this particular point, below this point Q1, 25% of the data is present. Q2, it is also called as median. It means that below this point, 50% of the data is present. This is Q3. This is 75. Okay, so below this particular point, 75% of the data is present. So this is how point means Q1, Q2, and Q3. And they are used in, okay, here we make box plot as a visualization to show Q1, Q3, and Q2. This is Q1, this is Q2, this is Q3. Also, for one more important thing, outlier detection. Outlier are fault or wrong entries present in the data according to statistical analysis. According, ये word लगाना जरूरी है. According to stats, these are wrong or faulty entries present in the data. They are called as outliers. Okay, so you have described your data. This is the data description. Then what I did is I tried to find, okay, how many what is the percentage of null values present in the data. So df dot is null dot mean. Take the mean, multiply by 100, and print it. Okay. So in time, no null value. In biomass, 5% null values are there. Here also 5%. 5%, 5%, 5%. Okay. In this hydro pump storage, 100% null values are there. Obviously, I'm going to drop it. And that's what I did. Okay, so it's showing the percentage of null values present in the data, and here I'm dropping. The two features which are having 100% null values, no sense of keeping them. That is generation, hydro pump storage aggregated, and forecast wind offshore. The code is like this: df equal to df dot drop, axis equal to 1 means column, and in a list, just enter the feature names. That's it. Dropped. After dropping, I checked unique values present in each and every column. What is the unique value in each and every column? So here it is printing in time 35,000, generation biomass 423, 956. So very simple, like df dot and unique. Okay, fine. So far, we have somehow what explored our data. We did some cleaning also. Okay, by dropping these two, okay, which is having, okay, so we did some cleaning also in our data. We checked the duplicates, we found the null values. Two columns I have dropped. Okay, still we do have the null values in rest of the columns. We have to take some action over that also. Okay, so some exploration we have done, some cleaning part we have done in our data analysis. Do you have any doubt? Please let me know. Yes, any doubt? Please let me know. You are patiently listening to me from long time. Any doubt? Please let me know. Yes, Mr. Akshar.
So when you mentioned the two parameters in df.drop,
Hmm.
you had to explicitly state
Hmm.
these two
Hmm.
parameters, or
Hmm. Yes. Yes.
because
Explicit.
tomorrow, let's say after 1 week, you get value in one of these columns,
Huh.
then then one of them maybe probably become redundant.
Okay, sir. According to my current data, sir, there is nothing available here.
Okay, so later on also, if the model evolves,
Okay,
is
sir.
there any way that we can
Sir, in
define a
the model,
condition?
now, since we dropped this in the initial phase, the model will not going to understand what these two are.
Okay.
Model will we have to, okay, once the model get trained, the model is going to train over the existing data, which you are going to finally, after all this analysis, after all this cleaning, after all this part of the feature engineering, everything what you have done, when your data is means absolutely clean, correct, valid, I will say the valid term, valid, when your data is valid, Then you are going to
Okay.
put it into the model, so that will be the final features.
At that time, we can then remove these, remove whichever parameter becomes present.
Ah, sir, we have already started removing. We found that there is nothing present here, so remove it. Here only, just remove it. There is no
Okay.
sense.
Okay. Thank you.
Okay, sir. So explicitly by writing these two features, I removed. Is any other thing? All right, all right. Okay. So if you don't have any doubt, okay, how you find the day one session? How it is? Day one session? Any feedback, please?
Very good, sir.
Yeah, it was quite
Did you
amazing.
understood?
Yes, yes.
Yes, sir.
Okay. And such kind of projects where the energy part is there, so it's never been easy. And I already told that still we have further more scope to explore what this feature means. Whatever from my end, I did explained. Okay, still because the terms are very technical to the electricity consumption and the power generation. Okay, so obviously, fine. You have to take some more time to understand that. Okay, let me do one thing. Fine. So, just a second. How to increase the efficiency of the model, sir? For once we do the model, na, then we will talk about the efficiency. Okay, we haven't done the modeling yet, so once we will do now, then we'll talk about the efficiency. Okay.
सर
Yeah, please say.
सर कोड इज एवरग्रीन सर.
कोड एवरग्रीन, हाँ, ये तो है सर, कोड एवरग्रीन रहेगा दिवेश, तुमको पता है मेरा पैटर्न क्या है काम करने का.
यस सर.
ओके, फाइन.
Hello, sir.
हाँ, यस यस मिस्टर संदीप से.
Sir, can I get code
हाँ हाँ, यस यस, यू विल गेट एवरीथिंग. आई थिंक आई हैव
and
ऑलरेडी
PPT
मेल्ड.
and PPT also?
हाँ हाँ, दिस नोट्स आल्सो आई विल शेयर.
Okay,
Okay,
thank you.
notes I will share. Code and this data set I've already shared, Mr. Sandeep.
Okay, sir. Thank you.
Let me stop.